going on, guys? Checking in here from my garage. I'm about to show you actually a little bit of a project I got working with some cells from Battery Hookup. These are lithium iron phosphate 32650 cells. If you watched the video I did with the scooter upgrade with the massive 33140 cells, this is the smaller battery that I referenced. So this one's a 6 amp hour cell, 3.2 volts, running 8 in series. I get up to a nominal voltage of 25.2. And this replaces, in a drop-in replacement, one of those Razor scooter batteries. These cells are pretty cool. I think they're rated for 3C continuous. They can pull us up to 50 amps. So obviously in a scooter it's pulling like 4. So nothing that even, would be getting close to its capabilities. But my goal is to not only show you how to put this into a scooter, but just also how these cells work. They're quite easy to spot weld. And they've got good specs coming from an American company with a lot of people who've used them and a little bit of a reputation that follows that. The benefit of Battery Hookup is, in spite of it being based in America, the price that these sell for is quite low, and depending on where you are, the shipping cost isn't too terribly expensive. I think each of these sells for like $270 a cell, but you can get a 5% off by just using the code DIY in the checkout. So the total pack cost for the cells was like $22 or something like that. Shipping from me being all the way across the country is a little bit higher. I think I paid $16 to get these 8 cells shipped. If you buy a larger quantity, I'm sure that the proportion of what the impact the shipping has goes down. So for me, it was like mid-30s to get this here. BMS was $10 more. That was from AliExpress, which I already had like 3 of these shipped in just because I have a lot of little plans for this type of a battery. But I'm about an hour and a half in, I would say, on this process. Pretty straightforward. I anticipate about a half hour more. I mean, I really just got to wrap this battery up and then change out the charge port. I anticipate that in this unit, this gets 15 to 20 miles, which pretty crazy. I mean, it's a immense downsize from the cells that came with it. There were 2 of these previously, and they're, probably one of these is the same volume roughly of this, and then the weight of it, one of these I would say is a little heavier than this here. So the weight reduction and the roughly doubling of range is going to be pretty significant. So out the door, I'm about $45 into this one. This is just over 150 watt hours. If I were to put together something for a bike or for a different unit that would use this, for a bicycle you'd want probably 4 times this size. And even at that price, you're looking at less than $200, even with the ratios of what I've got. You'd probably be doing probably $150, for a new battery if you're looking to rebuild something or for a build on a unit. So these are really an economical and reputable option for any of the battery plans that you've got. Big benefit is shipping time and just quality and confidence that you're getting what you're paying for. Plenty of batteries, if you're not sure who to buy from or what the cell's going to turn out like, you end up not getting what you were expecting. A lot of the discharge rates are inflated, things like that. We're planning to use Battery Hookup for a project after the Ducati. We're looking at getting a unit that'll discharge about 1,000 battery amps. Obviously you'll see that on the Ninjas channel after we get the Ducati finished up. So this will be just kind of like a trial run for utilizing that company. My hope is that we use headway cells for that second build. So anyway, that's the plan, and I'll let you guys follow along and we'll catch you at the end. Just got a delivery from Battery Hookup. Basically, I picked up a scooter for 20 bucks that was in perfect condition, minus batteries being a little bit worn out. And so I opted for the smaller cell replacement compared to the big one I did last time. It's about half the size of that one. So roughly 15 to 20 miles of range, most likely, out of these. 32650s, lithium iron phosphate. Fun fact, if you ever buy anything from Battery Hookup, that'll save you 5% on everything. I got 8 cells here, and those 8 cells will equal 24 volts. They use the same diameter of cell holder, so I'll use those same ones that I already have in stock in my garage. So I'll put this together. It'll be a drop-in replacement. That's the big benefit. All we gotta do is change the battery charging port, otherwise 100% drop-in replacement. So here's the scooter that battery is going into. It's effectively brand new. I bought it for 20 bucks, and the battery was a little bit tired, effectively was the only thing that was really wrong with it. And so I'm going to take the case off, the top off, and then kind of walk you guys through the plan a little bit. got it all cleaned up. These two free wires that I clipped are actually two wires that go to the circuit breaker, and so we'll reconnect those in on the positive side of the discharge. This was where the discharge plugged in, and so what I've done is I've just clipped off both the discharge, which will then connect to the new battery, and then the charge, which will also connect to the new battery. That will then plug in. This came off of the controller. I snipped it off right there. This will plug in to the existing charge cable. We'll bypass the controller because the BMS on the battery itself handles the charge cutoff. And all I had to do was cut off the one little thing that held the cell in. They laid flat like this, and there was a piece that separated those two out so that they wouldn't be touching on their leads there. The new pack is the exact same width as the previous cells, and so it'll lay flat on its side just like this does. It's about double the functional capacity. So this one pack, which sits flat, same way the other ones did, that bar will go right back across the top. Leaves that much extra space that was previously cells. So the weight of it is, man, it's less than half the weight of the total original weight. And it's, I mean, immense upgrade. All you gotta do is solder on two things and replace the charge port. These cell holders were designed for the 33 140 cells. These are 32 650 cells. And so the extra 1 millimeter of diameter is noticeable. You can see it wiggles around. I just repurposed them. Obviously I had to sand off the extra cell and the little connectors on the side to make it as form-fitting as possible. But with a little bit of hot glue to hold those in place, that'll be just fine. I did originally order fish paper. I thought it didn't show up. I'm not sure if I must not have ordered it. I had two separate orders. I must have skipped it on this one. And so what I'll do is I will just put a little plastic stopper on each of the positives. Risk being, there's already a plastic insulator ring here that was heat strengthened onto it. But if the negative discharge or the negative lead of the cell actually wraps around the whole cell, and if this wears through, you can short from positive to negative on top of a single cell. You don't need to insulate the negative sides, just the positive sides. And it's really just a extra precaution. You can get away without it. When I realized I didn't have it, I debated not putting something on at all, but I'm gonna put some insulator on there. So I just got some plastic. They were like shipping corner protectors. They're a thin ABS plastic. I'm gonna use those to insulate across the little gaps here so we can cover that positive and negative junction up there. And then I'm using nickel strips, the kind that you'd use with 18650 or other types of, weld top cells. I got my little spot welder here. It was about 110 bucks on eBay that we got for the electric sport bike from China long ago. You could solder just as, not quite as good of an option, but as long as you're doing a fast heat transfer, high-powered soldering iron, you could solder with just wire like I did with all of these cells here. And the other, lithium iron phosphate we've done recently. It'll damage the cells slightly potentially if you're not careful, but as long as you're careful with it, you shouldn't really lose much of the cycle life or the capacity on those. Quick summary before I close it up. Everything is complete. Charge cables coming off the battery are gonna plug into this charge port, which I turned into a DC, just a normal DC plug. And then I downsized this hole by using a piece of a trash can I cut up, and I just basically cut a square that I could glue to it with the hole cut to the right size. I didn't change any of the wiring. We still have one of these leads going to the switch. This discharge plug, which goes to the controller, I wired it through the circuit breaker. So I just snipped this, took the two wires that were originally attached in the battery on the circuit breaker. As you can see, I attached one here so that it runs through the circuit breaker, and the other one comes out and goes there. So this used to be connected to this. I just connected these two wires through the circuit breaker. Otherwise, aside from snipping this, running through the circuit breaker, putting a new charger port on, this is the exact stock setup. I just snipped off the charge and discharge that were previously going to the controller and to the old battery, and I just put them on this battery pack, since the BMS, which is here, now controls all of the charge function.